You know, we all do this probably dozens of times a day without even thinking about it. Logging in, username, password, click. But what's actually happening behind that screen? Well, in this explainer, we're going to pull back the curtain on that everyday action and unlock the secrets to how the digital world decides who you are and, maybe more importantly, what you're allowed to see.
So here's our game plan. We're going to start with that simple login, what we're calling the digital handshake. From there, we'll introduce the really powerful AAA framework that runs the whole show. We'll see how it works in the real world, tackle the kind of weird question of how computers prove who they are, and finally, we'll solve the absolute headache known as the permissions nightmare with a solution that is just surprisingly simple.
All right, so let's start with that familiar login screen. It feels so simple, right? But it's literally the front door to everything. This is where the entire security process kicks off, and it all starts with you making a simple claim.
So the very first thing that happens is what's called identification. When you type in your username or your email, you're not proving a thing just yet. All you're doing is telling the system, hey, I claim to be this person. That's it. It's just an introduction.
Okay, but now comes the most important part, authentication. This is the moment of truth. The system basically looks at you and says, oh yeah? Prove it. And you do that by giving it a secret that only the real you should know. Your password, maybe a code from your phone, your fingerprint. If that secret matches the identity you just claimed, the system says, okay, I believe you. Now, authentication is a huge piece of the puzzle, for sure. But it's actually just one part of a much bigger system that the pros call the AAA Framework. Think of this as the complete rulebook that controls everything: who gets in, what they can do, and keeping track of what they did.
So that first A, like we just talked about, is authentication. It's all about verifying who you are. It answers that one fundamental question: are you really who you say you are? This is the check-in desk.
But here's the thing, just because you're authenticated doesn't mean you get the keys to the entire kingdom. And that brings us to the second A, authorization. This answers the next question, okay, now that we know who you are, what are you actually allowed to do? You know, an employee in shipping and receiving, they should be authorized to see tracking systems, but there's no way they should be authorized to access the company's private financial records. And finally, we have the third A, accounting. You might also hear this called auditing. The system keeps a detailed log of pretty much everything you do. When did you log in? What files did you open? This creates a digital paper trail, which is absolutely vital for security, especially for figuring out what happened if something ever goes wrong.
So let's just put it all together one more time. First, you identify yourself. Then the system authenticates you to prove it. After that, it authorizes you for only the things you're supposed to see. And the whole time, it's accounting for your actions. That's the AAA framework in a nutshell.
Okay, so that's all the theory. Let's see how this actually works in a super common, real-world situation, connecting to your company's network from home with a VPN. Where do the keys to the kingdom actually live? You know, what's really interesting here is that the device you connect to, this VPN concentrator, it doesn't actually know your password. Think of it like a bouncer at a club. It takes your ID, but then it radios someone in the back office, the central AAA server, to check if you're on the list. That server has the master list. It checks your details, and if they're good, it sends back an approved message. Only then does the bouncer let you in. This is way more secure because all the secrets are stored in one single, heavily guarded place. Okay, so we figured out how to authenticate people. That's great. But what about authenticating things? I mean, how does the network know that the laptop connecting is a trusted company device and not just some random computer from a coffee shop? A laptop can't exactly type in a password, right?
Well, the answer is something called a digital certificate. The best way to think about it is like a passport or an official ID card, but for your computer. It's a special file stored on the device that's been digitally signed by a trusted source, and that signature proves the device is legit.
So who issues these digital passports? That would be a certificate authority, or a CA. The CA is like the central trusted passport office for the entire company. It creates, it signs, and it manages all of these device certificates. So when a laptop shows its certificate, the network checks with the CA to make sure it's valid and hasn't been canceled. It's a super secure way to verify a machine's identity.
All right, so now we can authenticate our users and our devices. We're golden, right? Well, not quite, because now we run into a new and honestly a massive problem. As a company gets bigger, trying to manage who is authorized to do what becomes a complete and total nightmare.
I mean,
Just look at this. For one person, it's easy. Give them access to this file, that printer, and this application, done. But now imagine you've got 500 people in one department, and they all need access to hundreds of different things. Trying to manually set permissions for every single person, for every single resource, it's impossible. It becomes this tangled, chaotic, and error-prone mess.
So this is the big question, right? This is what keeps security administrators up at night. How in the world do you solve this puzzle? How do you manage all this complexity without losing your mind, and more importantly, without accidentally creating huge security holes?
Well, the solution isn't to work harder, it's to work smarter. And we do this by using something called an authorization model. It's this beautiful layer of abstraction that makes everything so much simpler.
And the core idea behind it all is just breathtakingly simple and incredibly powerful. You create a group.
So how does this work? It's amazing. Instead of messing with 500 different user accounts, you just do 3 simple things. First, you create one group and call it shipping and receiving. Second, you assign all the permissions that department needs, access to the shipping labels, the databases, whatever, to that one single group. And third, you just add all 500 employees into that group. And boom! Just like that, they all instantly get the exact permissions they need. It's clean, it's simple, and it scales.
This quote from our source material really just says it all. Using these groups or roles, it just streamlines the whole process. It turns what could be a totally chaotic system into something simple and manageable.
So what's the big takeaway here? Well, it's that effective digital security isn't about building a million tiny individual rules. It's about designing smart, scalable systems. These authorization models, like using groups, are the blueprints that turn the potential chaos of managing thousands of permissions into an orderly, secure, and efficient structure. This isn't just a neat trick. It's fundamental to how big organizations work today.
And that kind of leaves us with a final thought. Just think about your day so far, logging into your email, your bank, your work network, even Netflix or Spotify. Every single one of them acted as a digital gatekeeper, and they were all using these very same principles of authentication and authorization. So how many times today have you already proven who you are and been handed the keys to your own little corner of the digital kingdom?